Yuma County, Arizona. 3,000 square kilometers of the harshest terrain in the American Southwest make up the US Army's biggest testing ground. Which means this uninhabited desert is anything but peaceful. This is the Army's biggest land combat vehicle, the mighty Abrams Tank, known as the Beast.
Beast is an absolutely amazing machine. Abrams is the best tank in the world, hands down.
Deployed in every US conflict since its introduction in 1980, these amazing machines have stood the test of time.
There's no tank out there that is more lethal, more maneuverable, more ability to provide shock effect on the battlefield. This is the ultimate ground combat system.
The Abrams M1 tank. Weighing as much as a herd of 20 elephants, this 70-ton combat vehicle is turbo-powered to reach speeds of 45 miles per hour. It carries 4 crew, the commander, gunner and loader in the turret, with the driver below in the hull. The Abrams is put together in Lima, Ohio.
I absolutely love this tank. There's no doubt about it. The first year that I was married, I spent more nights here on my tank than I did in my home, and my wife can verify that.
Former tank commander Bill Goyne is the project manager.
If we were going to kind of walk around the tank, this is what we call the front glacis of the tank. So you can see the driver's hole is right in there. So the driver's down inside the hole. The driver sits kind of a kickback position. He's laid back. He's got kind of motorcycle type controls. Where that sight is up there, you can see those 2 windows. That's the gunner's sight. So the gunner is the one that is primarily engaging with this. It's a 120 millimeter smoothbore cannon. Then you've got up on top here, you'll see there's a remote weapon station. Put a 50 caliber machine gun on there. Then you've got this kind of almost looks like R2-D2 kind of thing sticking up right here. That's the commander's independent thermal viewer. Over in this hatch here, that's the loader's hatch. That's where you're going to be reloading from because it's kind of the largest diameter hatch on the tank. And then back here, this is where the turbine exhaust comes out of. So it's great on a cold day. You can be back here getting warmed up. Soldiers live on these tanks, and so you can kind of hang things off of here. You can wrap up a burrito and hang it and set it there for a little bit. It'll get warmed up real quick for you. Great on a winter day.
Cooking burritos aside, the Abrams tank needs to be able to perform a variety of vital tasks. Maneuvering across the battlefield and providing accurate firepower while keeping its crew safe. But making all that possible requires solving a long list of huge engineering challenges. How do you power a 70-ton monster up to speeds in excess of 45 miles per hour? How do you protect its occupants against all the threats of a modern battlefield? And how do you create a vehicle capable of taming whatever kind of terrain is thrown at it? The Romans used interlocking shields to create a protective shell all around their foot soldiers. But if one man tripped, the strategy literally fell apart. In the Middle Ages, siege towers were all the rage. But they were slow and cumbersome and, being wooden, highly flammable. But in 1487, Leonardo da Vinci had a light bulb moment when he saw a turtle. But if anyone had ever built his wheeled wood and metal cone, they'd have soon realized its shortcomings. Over 400 years later, an engineering innovation emerged that changed the face of the world's battlefields forever. The tank.
So this is a Mark IV tank, and it's the first mass-produced tank of the First World War.
Former British Army Captain Patrick Bury is at the Tank Museum in Dorset, England, to find out how these machines came into existence.
Now, there's three basic things in tank design which this actually encapsulates. Protection, mobility, and you got firepower. And all those design elements are still seen today in the design of modern tanks.
As this is a drivable replica, Patrick's able to experience firsthand what it would have been like to ride this mega machine.
This is incredible! The amount of noise inside here and the vibrations off the tracks, it's just unreal.
It was the brainchild of William Tritton, Walter Wilson, and draftsman William Rigby, who came up with this entirely new type of war machine. World War I saw deadlock on the Western Front. With both sides dug into their trenches, crossing no man's land in between was seemingly impossible on foot. So the British government asked this engineering trio to devise machines that would allow troops to advance across this torn-up terrain, and crucially, get them over the enemy trenches. And this was their solution, the British tank, a tracked and armoured fighting machine.
The tracks are really an amazing design for the time because they spread the weight and they also are able to deal with the mud.
It travelled at 4 miles per hour, and the infantry walked behind it, using it as cover until they reached the enemy lines.
You just get a sense of terror. If you were in the trench, if you'd never seen a tank before, one of these was unleashed against you. And just slowly trundling towards you, firing its weapons. There's nothing you can do about it.
It took an 8-man crew to operate the Mark IV, all squeezed into its cramped interior.
This would have been the driver's position when this hatches up. You actually got a really good field of view. And then when you went into action, you'd close down this hatch like that. And you'll be using this periscope, which is just a tiny little slit. And obviously your sort of situational awareness is much more limited when you're in battle. Next to me, you would have had the commander of the tank. He basically is responsible for the direction and also the target indication. In the din, you know, he can tap the driver and tell him which way to go, but crucially, for the tank to move, he needs to communicate with the gearsman at the back. So often they would bang a spanner for the gearsman to stop. The driver would engage the clutch, the gearsman would change the gear. The tank track would either change direction, one would go, one would stop, and that would rotate the tank.
Many of these early machines broke down, and the crew were either poisoned by the fumes from the engine beside them or captured by the enemy. Despite this, engineers continued to develop this original design, and a tracked vehicle soon became a vital part of the military arsenal.
Although it's simple and basic inside and indeed out, it was really effective when it was unleashed against the enemy in the First World War.
In Lima, Ohio, former tank commander Bill Goyne and his team are standing on the shoulders of those early pioneers to build the most advanced tank ever made.
Really, it's drawing on pretty much every decade of tank innovation. If you go all the way back to World War I, it's a tracked vehicle, just like you see with the Mark IV. That concept hasn't changed. That no man's land that you just couldn't get across, well, that type of terrain still exists today. And this tracked vehicle solution is the best, most maneuverable in all of those types of difficult terrain. That's why we prefer this tracked solution still, even after 100 years of tank development.
The 20-meter-long tracks are made up of linked steel plates with reinforced rubber treads. Each track weighs a staggering 2.5 tons. Product manager David Moore oversees the process.
We hold the track up and over the road wheels. We're now joining the track with the last coupler, so we use that hydraulic actuator to pull the track together. And then once we adjust the final tension, it'll be done with the track tensioner on that last road wheel.
With the tracks on, the hull section is now complete.
At this point, it does look like a tank. That's a convertible. We call these convertibles at this stage because you can drive around a test track just like that.
Once fully assembled, those tracks mean that nothing can get in the beast's way.
Just because of the sheer weight of the vehicle, everything bends to its will going cross country. So because of that, you have this kind of smooth ride that you can really focus on using the weapon system. You can really focus on maneuvering. It's a very confidence-inspiring feeling that you have when you're inside the tank.
But for this mighty machine to be effective on the battlefield,
when the bullets start to fly, you're just trying to stay in the fight.
its crew has to be able to defend itself.
It's a life and death situation out there, and you want to be able to engage that target before it has a chance to fire back at you.
The US Army's biggest land combat vehicle is the Abrams Tank. The platoons in the field rely on the engineers back home to keep its capabilities up to date. It's a huge responsibility for project manager Bill Goyne and his team.
There's no second place when it comes to the battlefield, right? You either are the winner or you're in trouble. So in the back of our mind, there's always the tank crew. Isn't going to make them more effective because the cost of getting it wrong is too high. You can't put a cost on getting it wrong. We have to have the best tank that's out there.
Since its inception, the weaponry on the Abrams has been continuously improved and updated. Its first major modification in 1985 was replacing a 105mm cannon with a 120mm model. Its secondary weapon is a 7.62mm M240 machine gun. And fixed to the highest point of the tank, there's a 50 caliber M2 machine gun. As a former tank commander, Bill knows it's vital to find ways to control all this firepower in a simple, intuitive way.
There's a tremendous amount that's coming at you as a tank commander. You're on the radio, plus you're looking for targets, plus you're trying to maneuver. The bullets start to fly, and your pupils dilate, and you can't read anything, and your breath is going out of control, and you're just trying to manage, kind of yourself physically and still stay in the fight. So the engineering has got to develop a system that's usable under duress and allows the crew to work as a team. If it doesn't do that or detracts from that, then you've actually made it less capable.
In live combat, locating the enemy is crucial. Threats can come from any direction, at any time, day or night, in any climate or terrain. It's essential to be able to respond to danger quickly.
Every second counts when they're in combat situation.
Abrams Test Chief Greg Dudar knows the importance of rapid target acquisition.
It's a life and death situation out there, and you absolutely want to be able to detect, recognize, identify the target, and engage that target before it has a chance to fire back at you. A key component is to have situational awareness of anything that's around you on the battlefield, and that could come from any direction around you. It is tough, and that's one of the big things we're looking to enhance is awareness that the crew has when they're in the vehicle.
Coming up with ways to locate and defend against surrounding threats from inside a tank is a huge challenge for the current Abrams team, and one faced by engineers of the past.
And here we go. This is incredible.
Engineer Dan Dickrell is taking this 100-year-old French tank out for some target practice to discover how it radically changed tank design.
I cannot describe to you the noise, the vibration. It's like being inside a belly of a steel monster. It's very visceral.
Known as the FT, at under 5 meters long and weighing under 7 tons, compared to the Abrams, it's relatively small and lightweight. The brainchild of automotive engineer Adolphe Ernst Metzmeyer and renowned French carmaker Louis Renault, the FT was designed to be used in large numbers, with many sent at a time in a swarm to overwhelm the enemy. But what made this tank so effective was its ability to target the enemy.
You ready to go? All right, 3, 2, 1, go.
All the tanks built during World War I had a fundamental flaw. In order to get the gun pointing in the right direction, they had to reposition the whole tank.
Main gun slowly coming on target.
On the battlefield, this was highly ineffective.
And we're gonna call it right there. So about 48 seconds. 48 seconds to take the tank, spin it around effectively 180 degrees. If that was trying to kill us, almost a minute to turn this thing around. That's not very fast.
But the Renault FT solved the problem. It was the first production tank to have a turret that could rotate 360 degrees. To demonstrate the difference it makes, the tank will have to find the same target from the same starting position. But this time, it can give it some spin.
To rotate it, there's no motor. It's me, it's my power. And I have this strap, I'm strapped to it, I hang onto the handles, and I press with my legs as hard as I can to make this huge metal turret rotate around. It took the tank about 48 seconds to rotate the entirety of it 180 degrees to put the gun on target. I'm gonna give it a go. I got my stopwatch. Let's see how fast it takes me. 3, 2, 1, go. It's rotating. Whew, it's a little bit of effort. I took about 4.5 seconds. In a situation where every second counts, that's a huge deal on the battlefield.
The rotating turret was truly revolutionary.
The ability for the turret to rotate a full 360 degrees was a huge leap in battlefield effectiveness. To be able to see all around and then position this tank gun on whatever target I could see all over the battlefield, it laid the basis for the modern tanks we see today.
The 30-ton turret of the Abrams tank weighs almost as much as 5 Renault FTs. But incredibly, it can also rotate 360 degrees in under 10 seconds.
The turret can slew 700 mils per second. That's one of the many things that make the tank amazing, is the ability to move as much mass as it has just so quickly.
Like the FT, it can fire in any direction. But the big difference is that the Abrams locates its targets using state-of-the-art optics.
We can see the vehicle's sighting systems. We have the gunner's primary sight on the left, beneath the commander's weapon station. And then on the right is the CITV, the commander's independent thermal viewer. The sighting systems allow us to see at night. And then there's levels of focus and zoom that can be brought in to scan the battlefield for targets. The tank is not just hardware, heavy metal. There's also a lot of software, electronics, and high-tech equipment. There's 1.4 million lines of code on this tank.
All this high-tech feeds into the turret's interior compartment. This is the nerve center of the tank.
20 years ago when I was a tank commander, you felt like you were getting into a suit of armor. You and your 3 closest buddies, your tank crew. Now it's a little bit more like getting into an Iron Man suit, right? You're getting in there and there's so much tech.
Known as the basket, this space, just 3 meters wide, is shared by a 3-man crew. The loader's position is next to an armored ammunition compartment. The commander has controls for rotating the turret and firing the cannon or machine gun. The gunner down below has their own sets of sights and weapons controls. So what is it like to be at the controls of this powerful machine? former US Army tank commander Joseph Murrieta has first-hand experience of its capabilities.
We have ourselves in the tank commander seat. The tank commander has an extension of what the gunner sees so that he can verify. We also have usage of our 360-degree viewer. Gone are the days of having your head out and getting your own situational awareness, which was really hard for a tank commander to break because it's really comforting to be able to see outside your tank and see the battlefield. So now that generation is pretty much gone, and you have a new generation that's trained to be undercover, to use his situational awareness and to rely on his thermals.
This new generation are also operating the machine gun by remote control and controlling the cannon with a joystick.
Like any full-size video game in an old school arcade, you will just give the input left, right, down, and up. And then you have the trigger, just like everything else. So you have a gun here that weighs more than 15 tons. You can see how effortlessly it elevates and depresses. So when the tank is on uneven terrain and traversing, the gun will stay stationary to its target. So while the tank is traveling, the gun is basically looking like this inside. And the reason it's doing that is it's actually staying on target.
The cannon can lock onto targets up to 4 kilometers away, even when it's traveling at speed.
The vehicle can be moving up to 40 miles an hour over very rough terrain, and the weapon is stabilized. So from the gunner's standpoint, he's sitting still, and what that results in is accuracy on the move. That means he's going to hit what he's shooting at.
But hitting those top speeds requires serious motoring muscle.
So you've got a 70-ton vehicle, you want it to go over 45 miles an hour, and what does it take to do that? It's all about the speed of the battle. It's being able to outmaneuver. That's really the hardest part of the engineering.
Red, this is Red 1. Engage tanks. Fire when ready.
The iconic Abrams M1 is the US Army's main battle tank. Keeping it ahead of the field over 4 decades of service is a great achievement for former tank commander Bill Goyne and the team involved in building this unique vehicle.
From an engineering perspective, it's right at the edge of what's capable. Even though from the outside it doesn't look like it's very different than what we fielded, 40 years ago, on the inside, it's completely different. The most updated electronics you're going to find on the battlefield are stuffed inside of this. But frankly, we're not allowed to even talk about what some of these technologies are that are packed into the inside of this tank.
A tank is effectively 2 separate machines in one. The turret controls sights and weaponry. The hull is its set of wheels. Almost 10 meters long, the rear is elevated to house the engine with the driver's compartment at the front. The turret and the hull are worked on separately on 2 giant assembly lines, overseen by David Moore.
When the turret finishes at the end of the line, the turret then gets its final gun shield, the turret basket guards on. At that point, we'll load it onto the finished hull.
Joining the 2 together calls for millimeter-perfect precision engineering.
We call it marrying a turret. You'd probably guess what we call it when we have to pull the turret off the vehicle. We call it a divorce.
Once the 2 halves are united, the combined weight is an incredible 70 tons.
This one looked like it's about ready to go for a ride.
So how is it possible to get this mighty machine moving at high speed?
One of the key tenets of armored warfare is shock effect. So you want to shock the enemy by moving at them so fast that they have very little time to react. It's all about the speed of the battle. It's being able to outmaneuver.
This presents a critical conundrum. The tank needs enough power to go all out, but if the engine itself adds too much weight, it becomes less maneuverable.
You've got a 70-ton vehicle, you want it to go over 45 miles an hour, and what does it take to do that? That's really the hardest part of the engineering, is getting that balance right. You need to have something that's giving you all the power that you need, but as light as you need it to be.
Designing an engine that's heavy-duty but lightweight seems an impossible mission. Solving it requires imaginative engineering from the past.
Starter light showing engaged. Little booster pump shoving some fuel in. It's running on its own.
And there we go. Wow.
Aerospace engineer Ben Evans is taking to the skies in a pioneering aircraft that may hold the key for the team working on the Abrams Tank.
That is an incredible feeling. Yeah, you really sense that this is a powerful machine, don't you?
It's lovely.
Mike Kurtel owns this iconic 1963 Alouette 2 helicopter.
The Alouette 2 helicopter really became one of the most influential helicopters in the middle of the 20th century. It set the trend for modern-day helicopters.
The first helicopters were powered by piston-driven engines like those used in cars. And as the aircraft grew in size, so did their engines. But ambitious helicopter designers struggled with this weight problem.
They wanted to make helicopters bigger and more powerful, which meant bigger engines. But increasingly they were finding that as helicopters got bigger, more and more of the power from those piston engines was actually being used to lift the weight of the piston engine, and not the thing the helicopter wanted to lift, which was the cargo or the passengers.
They faced the same problem as the team behind the Abrams Tank. They needed an engine that was powerful but lightweight. In 1950s France, one man came up with the perfect solution. Józef Skidowski was a Polish-born engine designer who pioneered the use of the turboshaft gas turbine engine in helicopters. The Alouette 2 was the first mass-produced helicopter to use the new engine.
So basically what we've got here is a jet engine, but instead of generating thrust, we're generating mechanical power down a shaft. This is one of the air intakes, and there's another one on the other side of the engine. It's sucking air in at the front of the engine here, and that air passes into a compressor. That compressor is squeezing the air, increasing its pressure and its temperature before it passes into the combustion chamber. So in this region here, fuel gets added and ignited, and then you end up with lots of hot, high-pressure exhaust gases which need to escape somewhere. And they come out of the back of the engine through the exhaust. But unlike a jet engine, where those exhaust gases are accelerated into a jet to push the aircraft forward, what we have inside here is a turbine. And that turbine is connected to a shaft running down the center of the engine. And you can actually see the shaft coming out the front of the engine here into this gearbox system here, converting that power and sending it vertically upwards into the propeller system.
The key elements of the turboshaft engine are the compressor, which provides the pressurized air for added turbo power, and the turbine, which turns the shaft that spins the rotors. Although the engine weighs just 143 kilograms, it generates 530 horsepower.
So this engine system is revolutionary because you can generate more power for less weight than the conventional piston engines that were being used before the Alouette 2. This makes it perfect for something like a helicopter where you need a lot of power, but you really need to keep the weight of the aircraft down as low as possible.
Delivering maximum punch for minimal weight, the turboshaft engine took helicopter design to new heights.
The turboshaft really was a game changer, and what this allowed designers to do was to build bigger and more powerful helicopters.
So how can the team building the Abrams battle tank make use of a helicopter engine? By supersizing it. This gargantuan gas guzzler is a 1,500 horsepower version of Skidowski's gas turbine turboshaft. In tank terms, it's known as the power pack.
What we've got here is what we call a full-up power pack. It has the AGT 1500 gas turbine engine, basically the same kind of turbine that you'd find in a helicopter. So this will kick out the 1500 horsepower that we need to move the 70-ton beast.
At 1.25 tons, it's a whopper, but it's the optimal power-to-weight ratio. A diesel engine with the same output would weigh twice as much.
So the turbine is actually about here. It's very small. So you have the air that's coming in through where this kind of red bag is, goes in through a compression stage just like you'd find in any other jet engine. We've got our turbine. The turbine is spinning. There's a shaft that goes right through here and interfaces here into the transmission. And this transmission here, all that power gets translated out these final drives that attach to the sprocket, drive the track of the tank.
The engine may be super powerful, but it doesn't make a lot of noise. This gives it a key strategic advantage.
So what you're hearing right now is the turbine sound of the engine. Most tanks are going to be diesel, and so you're going to hear them. They're going to be very loud, very smoky. But as you can see with this turbine here, there's almost no visual signature. Although it sounds loud to us on the battlefield, this is actually very quiet. You can be within a few hundred meters of this in the forest, and you won't even hear it at all when it's running. Makes it more survivable, because if you can't be seen, you can't be hit. And so that's what's great about the turbine engine. Oh, it's the greatest sound in the world. It has such a unique quality to it, and it just sounds like high performance, right? It sounds like it's ready to go. It's just chomping at the bit. That's the real advantage that we get from an engineering perspective over a diesel engine is you effectively have immediate torque, meaning when you turn the throttle in this one, the tank's gonna move. It's going to move immediately.
I think we're ready.
Yeah, we're good.
There's only one way to put the engine through its paces.
Engine firing up.
By taking it for a test drive at the proving ground in Yuma, Arizona.
All right, we're about to go out on course.
Today, Test Chief Greg Dudar is taking the Abrams off-road.
And we do testing out here, and we test on all the road surfaces. We're ready to roll.
The Abrams can go from 0 to 20 in 7.2 seconds.
20 miles an hour, no problem. Open her up a little bit.
And has a top speed of 45 miles per hour.
It's quite amazing, but it can be propelled this fast. It's actually a pretty smooth ride. We sure are riding in an Abrams.
The engine can run off most types of fuel. And although it does less than a mile to the gallon, it gives the tank the turbo force it needs.
It's always a good day to be out here and experience the power of the Abrams.
But before it's sent into combat, the #1 priority for the engineers is working out how to keep the tank crew safe.
How can we make this vehicle more survivable? And that's a real challenge for us from an engineering perspective.
This giant facility in Ohio is the ultimate tank factory. Birthplace of 10,000 Abrams tanks, each one an epic build incorporating the latest in military and mechanical engineering.
This one looks like a zero defect tank to me.
David Moore supervises this supersized assembly.
As the product manager, I oversee them all the way through the process to when they're delivered. All these tanks I consider my babies. Right now we have a completed tank. Gave them a final coat of paint and then put it onto a rail cart. And once they get a train load, we ship them. It's quite a sight when you see these tanks line up. They'll line up till you get a row of 24 of them or more. It's pretty impressive.
Before they're sent into the field, each one has to undergo a series of vital tests at the military proving ground in Yuma.
Let me know when you're ready for a round of load.
Today, Test Chief Greg Dudar and his team are test firing the cannon on this newly built tank.
The test crew are unloading ammo, and they're gonna bring it into the safe compartment in the tank as we prepare for firing. We're gonna be in a safe location behind a blast shield. We expect to see a big bang and a large fireball. And you'll feel it. You can actually feel the sound waves in your body. So, never a dull day when you're out at the test site testing tanks.
Roger, guys. Clear to load?
What they're doing right now, the weapon's been loaded. They're going through all their weapon checks, and they're gonna go ahead and fire the weapon.
Roger. Clear to fire.
They get the on-the-way command. There you go. Hard to beat. That was amazing as always. It never gets old. I love the smell too. Serious shock waves, serious power. Lots of energy being released.
The tanks must deliver force, but they also have to withstand it. The biggest challenge facing designers like Bill Goyne is keeping its defenses up to date.
Just like any other business, ultimately there's competitors that are out there that are constantly putting out new products with new capabilities, whether that's a new munition that we have to be worried about or some new threat that we have to be worried about. Because of that, we're constantly looking at what new technologies can we put in? How can we make this vehicle more survivable? And that's a real challenge for us from an engineering perspective.
Using the best possible armor has preoccupied tank engineers since the beginning. Originally, tanks were all made from steel plating. But post-World War II, as weaponry became more powerful, new armor had to be developed. And when a new type of anti-tank weapon appeared, for tank engineers, once again, the pressure was on.
Firing! 3, 2, 1! Wow, that was a big bang.
Physicist Andrew Steele is at a secret location in the British countryside to find out what they were up against.
This steel represents the armour plating on our tank. We've got 4 2.5 centimetre thick steel plates. There's 10 centimetres of armour in all. And as you can see, there's a pretty big hole in that. And if we go through number 2, there's a hole. Number 3, there's a hole on both sides. And finally, number 4, there's a pretty big hole in that one too. It's gone straight through. So what sort of weapon could blow a hole in 10 centimetres of steel? Well, I've got a little model of one here. It's called an RPG, or rocket-propelled grenade. In here, you've got your high explosive crammed in the back, and when that explodes, it crushes this inverted copper cone. It turns it into an incredibly hot, thin stream of copper metal, and it just cuts through it like a hot knife through butter.
Engineers had to find a way to defend against these new weapons. In the 1960s, German ballistics scientist Manfred Held discovered the solution by accident. He was experimenting, firing different projectiles at disused tanks. Some of the shells hit the area of the turret containing leftover ammunition, making it explode outwards, often deflecting the missile, preventing it from penetrating. This discovery would prompt Held to create a revolutionary piece of military hardware.
What we've got here is a modern version of Held's invention. It's called an explosive reactive tile. The top layer is just this very thin piece of steel. Inside, we've got a couple of bits of foam, which are representing the high explosive. And then on the back, we've got a much thicker steel plate. Now imagine an RPG impacting on this tile. What happens is that thin, hot jet of copper pierces this outer layer very, very easily. And that then detonates this high explosive inside. And what that does is sends this front piece of steel flying, which is why it's known as the flyer plate. That means this piece of steel can deflect the RPG, deflect that explosive energy away from the thicker plate behind, and keep the tank and its occupants safe. So what you want to do then is place loads and loads of these plates all over different parts of the tank. Might seem like a counterintuitive idea that covering the exterior of your tank in explosives can make it safer, but this simple invention is very effective.
To see it in action, the team's creating a reactive tile to try to protect a new set of steel plates from another blast.
We've got 10 centimetres of steel plate back here, but this time in front of it we've got 2 mil of steel, and then just in there we've got a couple of little sheets of SX2 high explosive, which is representing that tile of explosive reactive armour. Let's go and set this thing off. Arm the explosives. Firing! 3, 2, 1! Whoa! Wow, this is a scene of total destruction. If we come down here, have a look through the rubble, you can see this is a piece of that flyer plate, the thin bit of steel that was on the front, and as you can see, it's been pretty heavily deformed. Now, our 4 steel plates are, well, nowhere to be seen. They've probably been thrown back somewhere into that pile of rocks. If there was the weight of a tank behind them, they'd still be in place probably, but because they've just been completely free to move, they've been scattered by that huge, huge explosion.
Once all 4 plates have been found,
that's warm as well. Wow.
It's possible to see whether they've been protected from the blast.
You can see here we've got piece of armour number 1. You can tell that because it's got a really big hole in it and because it's got this indentation here where the high explosive was just pressed directly against it. Then we go through to plate 2, still quite a big hole, a little bit of a dent. Plate number 3, you can see that jet has been split into 2, disrupted by that explosive reactive armour. And finally, plate number 4, you can see still 2 jets, but they've not quite made it through to the other side. So we've saved our tank and we've saved its occupants.
The success of the exploding reactive tile turned armour design towards a totally new concept: fighting fire with fire.
Held's invention was a real game changer. Just by adding a thin layer of explosive and a thin layer of steel on top of existing armour, you could massively improve the safety of the crew inside.
The team working on the Abrams adopted this technology and developed their own exploding tiles that can be added to its outer shell.
The reactive armor on the Abrams mounts to the skirts, so that the skirts are replaced with a very similar but different version, and then the tiles, they're called, are slid all the way down the hull. That provides protection for the hull, for the tank itself, and also the driver.
The Abrams reactive armor tiles, known as ARATs, are fitted to each side of the tank. Flat box tiles are attached to the hull and turret. Then an additional layer of curved tiles are hung over the top of the hull, just like Held's original invention. If they're hit by an incoming shell, they'll detonate.
It is an incredible technology. We do ballistic testing on the performance of the tiles themselves, and what it does is it creates just a tremendous explosion and very loud noise, not unlike the weapon firing. I'd say the ARAT is critical for certain threat environments. When you're operating the vehicle, having that protection increases the chance that the tank is going to survive any time it gets engaged.
If I was to go into combat again, this is exactly where I'd want to be. There is no safer place to be on the battlefield than inside of this vehicle. The things that can be updated have been updated, and the things that worked really well, no reason to break them. That's why we're sticking with this tried and true design.
The Abrams tank is a victory for impossible engineering. After 40 years of service, this powerful piece of machinery remains the Army's top gun.
The original designers of the tank are really truly amazing to me that they built so much margin into this tank. And it's a testament to the longevity of this tank that we can still make upgrades to it and it can still maintain its performance over such a long period of time.
It's a constant battle to produce the best machine.
Engineers are curious and like to work problems, and there's a lot of things for us to do in order to deliver something this complex, but it's almost impossible to keep up with the latest technologies that are out there.
But driven to do their utmost for the tank crews, they're building on pioneering innovations of the past and creating new capabilities for the future to make the impossible possible.
We believe this is the best tank built in the world. Everybody's in awe. It's bigger than they imagine. It's faster than they imagine. We take great pride in what we do, and it brings the soldiers home.